Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 17 in the cross-site scripting module titled Reflected XSS into HTML Context with most tags and attributes blocked. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy. Select all labs, do a search on cross-site scripting labs, and go to lab number 17, titled Reflected XSS into HTML Context with most tags and attributes blocked. Alright, let's get started. This lab contains a reflected XSS vulnerability in the search functionality but uses a web application firewall to protect against common XSS vectors. To solve the lab, perform a cross-site scripting attack that bypasses the WAF and calls the print function. And we've got a note right over here saying your solution must not require any user interaction. Manually causing print to be called in your own browser will not solve the lab. So the victim user that will be sending this malicious link to will not perform any action in the browser, and therefore we need it to trigger when the user just visits the link. All right, so the target goal over here is to perform an XSS attack that bypasses the WAF and calls the print function. Let's access the lab. Now notice over here, this is the built-in browser in Burp, and so all my requests are already being passed in my Burp proxy. I am using the professional version of Burp, however, all the features that I'll be using are also in the community edition. It just Intruder is much faster in the professional version, and so I've decided to use the professional version for this lab. All right, so the first thing that we do when it comes to testing for cross-site scripting vulnerabilities is we look for client-supplied parameters that are reflected back in the application. So we've got a search functionality over here. The first thing I'm going to do is just put in a string and click on search and see if my string, which is a client-supplied input, is reflected back in the application. And as you can see over here, it is reflected back to me. And so this field needs to definitely be tested for cross-site scripting vulnerabilities. The first thing I'm going to do is test a really common exploit. So we'll use the script tag to call the alert function and see if the application allows us to use that tag. So let's click on search and we get tag is not allowed. So just like the description said, there is a web application firewall or a WAF that is filtering some of the tags. And in this case, the script tag is not allowed. So the next step over here is to figure out which tags are allowed so that we could bypass the firewall. So let's just keep script right over here. Click on search again and send this request to Intruder. And in Intruder over here, we're going to clear on everything except this right over here. So this doesn't really need to be URL encoded. So I'm just going to remove the URL encoding over here and add this. So essentially what we're going to do is we're going to try all the different possible tags over here. And whenever we get a tag is not allowed or an error code, that means that that tag is not allowed. However, if we do get a 200 OK message, that means the tag is allowed. So for that, we're going to go to payloads over here and we're going to add our payload list in here. Now to get the list of tags, we're going to Google XSS cheat sheet portswigger. Hit enter and it should be the first entry over here. So let's click it. And this is a really, really useful resource for cross-site scripting. It essentially has all the tags and then the custom events that you could use on each tag and so on. And it does it for each browser. So for now, we're just going to copy all the tags, paste them in here, and then try all 152 tags to see which ones work. And this is why I'm using the professional version. You could still use the community edition. It's just that the professional version is much faster and I don't want you to sit and wait in the video while I wait for the automated attack to complete. So let's click on start attack. And so far you could see there's a ton of 400s, which means that they're not allowed. But you could see over here there's a 200. So let's order on status to see what's allowed. So we've got body tag is allowed and then custom tags are allowed. Let's try with body tag, and if it doesn't work, we'll go for the custom tag. So let's close this off over here, discard. and just test it over here. Let's go back and just put in the body tag to confirm that it is allowed. Hit search. And here we go. So we don't get that custom error from the WAF. We get a 200 OK message, and you could see over here it's not reflected back to me in the input, which means that it's being viewed as client-side code. So the next step over here is to copy the events to clipboard and see which events are allowed. And then let's clear this, paste it in here. So these are the events that we want to test to see which ones are allowed. And then in positions over here, we no longer need this. We'll just put the body tag. And then let's just say event, I'm making this up as I go, is equal to, let's say 1. So over here, this is the field that we want to test for valid events over here to see which events work. Now first, let's URL encode this. So Control U to URL encode it. And then over here, let's add this to the list to make sure that's the field that we automate. All right, so what it'll do is in this field, it'll try each and every payload. So let's click on Start Attack. And again, you see a bunch of 400s, but you also see a bunch of 200s. So let's order on the 200 OK messages, and we're allowed to use on before input, on resize, on scroll end, on after print, and so on. I'm going to go with on resize. So over here, we already have the body element selected, and then I'm just going to look for on resize. And here we go. And then it just gives you the code for the XSS vulnerability over here, which is why I said this tool is really, really useful. And even better, because we're testing with Chrome and the victim user is likely going to be using Chrome, you could select which browser and then it'll only show you the code that will work on that browser. In this case, this is compatible with all of them. So I'll just copy this over here and put it in here and then go back to our application and then add it over here and click on search. Now notice over here, when we resize the browser, it should present us with the print functionality, and it does. So let's cancel over here, and it'll do that on a loop, which is not great, but let's close this over here. Now we know that our script is working, and let's access the lab again. Now, the issue with this is that when you try to do this with a victim user, what you're going to do is essentially send them this link right over here. So if we go back to proxy and look at the request that was calling the print functionality, it's this one right over here. If you copy this, add HTTPS to it, and then go back to proxy, and we don't need this anymore. Let's close this off. And then copy the payload. If you send this link to the user won't be presented with the print function. And to demonstrate that, let's copy it and just go to a new browser. So let's say Firefox, and then try it right over here. You could see the user is not presented with the print function. And the reason is because this is only triggered when you actually resize the window. And unless the user resizes the window, the user will never be prompted with the print functionality. And the lab did say that the user won't be performing any actions. And so that's why we need to add a little bit of extra code in order to resize the browser itself, or maybe an iframe, and then it'll automatically work when we send the exploit to the user. And for that, we're going to use the exploit server, which is just our attacker-controlled server. In here, we're going to see if the application can be framed. So most applications can't be framed because it opens an attack vector for clickjacking attacks. But let's see if the application can be framed in this case. So let's say src is equal to the URL to the application. So let's copy this, paste it in here, and then just close it off and close off our iframe. Let's view the exploit. And you could see over here, what we're doing is we have an iframe, and then we're just loading the page in the iframe. So what we're going to do right now is essentially perform the resizing option in the iframe itself, and therefore it'll be an automated process where the user won't have to do it themselves. So to do that, the first thing we're going to do is just copy this entire thing over here and put it in here. So this will trigger the print functionality, and then we're going to say onload this dot style dot width is equal to 100 px. And I'll copy this and put it in here, and I'll add the link to the document, so the notes.txt document, in the description of the video. All right, let's deliver our exploit to the victim user. If the user is presented with the print functionality, you should see, congratulations, you solved the lab message. All right, so we successfully completed the exercise by exploiting the reflected XSS vulnerability to call the print function. In the next lab, we'll look at another case of a cross-site scripting vulnerability.